Hey everyone, my name is Mayank Jindal. Thank you for joining me today on Embracing MLOps, Bridging the Gap Between Machine Learning and DevOps. I will talk about what is MLOps and how it is different from traditional DevOps. I will also describe the importance and challenges of MLOps. Little bit about me. I'm working as a software engineer in Bay Area in United States since last 4 years. My focus is on building AI-powered scalable software systems. In the past, I have contributed to open source a lot. Previously, I graduated from University of Chicago with masters in computer science and from IIT Kharagpur with bachelor's in civil engineering. Little disclaimer before I start, the views and opinions expressed in this talk are personal and do not reflect the critical policy or positions of any other agency, organization, employer, or company. Agenda for this talk is as follows. First, I will be giving some introduction about machine learning and MLOps. Then I will be talking about why MLOps is important. Then I will be talking about what is the difference between MLOps and DevOps. And then what is the unique characteristics of ML models which makes it different. Then I will be talking about challenges and collaborations, then best practices in MLOps. Then at last, we will leave some time for questions and answers. Okay, so what is machine learning? Machine learning is a powerful technology that allows computers to learn from data and make decisions or predictions based on that learning. The journey of creating a machine learning model involves several key phases. Each of those is critical to ensure that the model performs well. Let's break these down one by one. First is data preparation. This is where we get the data ready for the model. It involves collecting data, cleaning it to remove errors or irrelevant information, and organizing it in a way that the model can use. Then model training. Once we have prepared our data, we can start training the model. This is where the machine learning algorithms learns from the data. Then evaluation. After training the model, we need to test it to see how well it has learned. We can use separate data that the model hasn't seen before to check its predictions. Then deployment. If the model performs well, it's ready to be deployed. This means putting the model into a real world or production environment where it can start making decisions or predictions based on the new data. Then monitoring. Once deployed, we need to keep an eye on the model to make sure that it continues to perform well. Over time, as it encounters new data, its performance might change. Monitoring is like getting regular health checkups to ensure everything is working as expected. Then, maintenance. Based on what we find during monitoring, we might need to update or tweak the model to maintain its performance. It could involve retraining it, the model with new data or adjusting some of its settings. So now coming to MLOps. MLOps stands for Machine Learning Operations. It is a set of practices designed to deploy and maintain machine learning models in a way that is both reliable and efficient. Essentially, MLOps sits at the intersection of machine learning and software engineering. This integration aims to streamline the entire machine learning lifecycle from data collection and model training to deployment and monitoring. It ensures that the delivery of machine learning models to production is quick and consistent. Now, why MLOps? What is the need of it? MLOps plays a critical role in the world of AI and machine learning by significantly improving the way we deploy machine learning models. The primary reason for highlighting MLOps is its ability to speed up the deployment process. By streamlining workflows and automating repetitive tasks, MLOps enables team to move models from development to production much faster than traditional methods. Another key benefit of MLOps is operational efficiency. With MLOps, organizations can manage their machine learning models more effectively, ensuring they run smoothly and reliably. This operational efficiency is crucial for maintaining the performance of models over time and reducing the downtime that can impact business operations. Another factor is collaboration. It improves teamwork by bringing together data scientists, developers, and operations team. This collaboration is essential for overcoming the challenges that often arise due to machine learning projects, like, for example, aligning model objective with business goals. Another aspect is scalability. Scalability is also a significant advantage of MLOps. A machine learning applications grow, managing them can become increasingly complex. MLOps provides the frameworks and tools needed to scale up machine learning operations without sacrificing performance or security. Lastly, governance is an essential aspect of MLOps. It ensures that machine learning models comply with industry standards and regulations. It is particularly important in sectors like finance and healthcare, where models must be transparent and explainable. Now let's talk about the difference between MLOps and DevOps. When we talk about MLOps, we are looking when we talk about MLOps and DevOps, we are looking at two related but distinct areas of technology. The main difference lies in their focus. While DevOps centers around code and how to develop, deploy, and manage the code efficiently, MLOps adds an extra layer by concentrating on machine learning models. The difference is crucial because, unlike traditional code, machine learning models requires continuous training to stay accurate and relevant. Coming to continuous training, in MLOps, models are regularly updated with new data to adapt to changes and improve over time. This concept doesn't directly apply in DevOps, where the focus is more on ensuring that the software continues to run smoothly after any update or changes. Data dependency is another area where MLOps diverges from DevOps. Machine learning models depend heavily on data quality and quantity. It means that managing and monitoring the data becomes as important as the model itself in MLOps, which is a concern that doesn't usually apply in traditional software development and operations. Finally, monitoring and performance takes on a different context in MLOps. While both fields emphasize the importance of monitoring, MLOps requires specialized tools and techniques to track the performance of machine learning models, including how prediction changes over time and how well the models are adapting to the new data. Now, coming to unique characteristics of machine learning models, there are few unique characteristics like model versioning, data drift, model performance monitoring, and continuous training. I will go through these one by one. First is model versioning. Model versioning in MLOps is like keeping a detailed diary for machine learning models. It's all about tracking and managing changes to models over time. Just like we might note down importance events in a diary, model versioning records every tweak or adjustment a model undergoes. This process is very crucial in managing model iterations effectively because it ensures that every version is accounted for and can be revisited if needed. The components involved in model versioning are quite straightforward. First, we have model artifacts. It includes the model itself along with its parameters and any associated code. Then there is a data versioning, which ensures we keep track of which data version is associated with any particular model version. Lastly, experiment tracking allows us to record different experiments, including the settings used and the outcomes, so we know what was tried and what worked best. Model versioning comes with its own challenges. One major issue is storage overhead. Keeping a record of every versions of a model and its data can take up a lot of space, especially with large models and large data sets. There are few strategies which can be used. One is efficient storage solutions. We should opt for storage solutions that are optimized for large files, typically which we found in machine learning, such as object storage service that offers scalability and cost effectiveness. Compression techniques can also reduce the size of stored model artifacts and datasets. Another is selective versioning. Not all model iterations need to be saved forever. We should implement policies for pruning older versions that are no longer relevant or have been superseded by significantly improved iterations. It can be automated based on criteria like performance metrics or time. Another is incremental versioning. Where possible, we should use incremental versioning techniques that save only the changes between versions rather than duplicating the entire dataset or entire model. This approach significantly reduces storage needs. Then there are complex dependencies to consider. It is not just about the model, but also about the data it was trained on, the environment it was trained in, the code used. Managing these dependencies so that a model can be recreated or rolled back to a previous version requires careful coordination. Few things can be tried out for it. One is centralized artifact management. We should use a centralized model registry or artifact repository where all model versions, along with their data and configuration files, are stored. We should also establish and document best practices for versioning and dependency management within the team or organization. Education and training can ensure that all team members understand and adhere to these practices, reducing the risk of errors and inconsistency. Another aspect is data drift. Data drift is a term we often hear in the context of machine learning. It refers to the change in the distribution of model input data over time. Imagine we have a garden, and over the seasons, the type of flowers and their colors change. Just like we would notice these changes, in machine learning, we need to notice that when our data changes, because it can make our model less accurate or even lead to incorrect predictions over time. So, why does this matter? Because when the data or models are trained, it starts to differ from the new data they are receiving, then their performance can go down. It is similar to studying from an old textbook for a test that is based on a new edition, and then we can find some surprises or mismatches in what we have learned versus what was asked. So, how do we catch these drift? There are few ways. One is statistical test. These are like tools for checking if the types and patterns of flowers in our gardens have changed significantly. We use specific tests to compare old data with the new data and see if there is a noticeable difference or not. Another is performance monitoring. This is like keeping an eye on the health of our garden. If certain flowers starts to change the color, meaning that if our model's accuracy drops, it might be a sign that the conditions like the data have changed. Another is visualization. This is similar to taking a step back and visually inspecting the place. By looking at charts or graphs of our data over time, we can often spot shifts in trends or patterns that might include data drift. Next is performance monitoring. Performance monitoring in MLOps is all about keeping a close eye on how well machine learning models are doing once they are out in the real world. It's a key to spotting problems early before they can cause bigger issues. By using a mix of metrics, team can understand not just the model's accuracy, but also how it is performing from a technical and business standpoint. Accuracy metrics like precision, recall, and F1 scores tells us how correctly the model is predicting outcome. These are important for ensuring the model is still doing its job as expected. But there is more to it than just simply accuracy. Operational metrics like latency, which is how fast the model is responding to traffic, or throughput, which is how much work it can handle. These are crucial for making sure that the model works smoothly and efficiently in a live environment. Then there are business metrics, like how much users are interacting with a feature powered by the model, which is like user engagement, or how much it is boosting sales, which is sales conversion. These metrics help teams see the direct impact of their models on the organization's goal. To stay on top of all this information, alerts and dashboards can be used. Alerts notify teams immediately when something is not right, like if accuracy drops suddenly or if the model starts working slower. Dashboards, on the other hand, provide a visual overview of all these metrics, making it easy to monitor the model's performance. Continuous training in the world of machine learning. It is all about keeping models up to date and in tune with the latest data. It's like giving our model a regular health checkup and training to adapt as the world changes around it. This is especially important in areas where what users want or how they behave keep changing quickly. To make this ongoing learning feasible, we can often set up automatic retraining pipelines. These are like machines that regularly feed new data into the model, retraining it to understand and adapt to recent trends without us having to manually intervene every time. It's about making the model self sufficient in its learning process. Then there is incremental learning, which is a smart way to teach models new tricks while ensuring that they don't forget the old ones. This method is valuable because it preserves the knowledge the model has already gained and building on it with new insights rather than starting from scratch every time. Model version control is another key piece. We can save different versions of our model. This practice gives us a clear view of how the model has evolved over time, helping us understand which change improved the model and which change didn't improve the model. Plus, if a new version of the model doesn't perform well as expected, we can easily roll back to an earlier version, ensuring reliability and performance are always good. Navigating through the world of MLOps presents several challenges that teams need to overcome. First off, the complexity and volume of data can be really scary. With vast amount of data to process, teams must rely on scalable data processing frameworks that can handle the load efficiently without sacrificing any speed or accuracy. Moreover, maintaining data quality is very important. This is where data quality frameworks come into play. It ensures that the data feeding into model is clean, well organized, and representative of the real world scenarios the model aims to address. Another hurdle is model complexity. As models become more sophisticated to improve accuracy and cover more scenarios, they also become harder to manage and debug. This complexity can slow down development and make it challenging to identify where things might go wrong. To address this challenge, we can use model simplification strategies, which will seek a balance between our model performance and manageability. Simplifying models without significantly impacting their effectiveness requires careful planning and testing. Next, skill gaps and the need for effective collaboration across diverse teams increase significant challenges. Breezing these gaps and fostering a continuous learning environment are crucial for the successful adoption of MLOps practices. Teams must work together seamlessly, sharing knowledge and learning from each other to navigate the complexities of machine learning project. Next is collaborations. So MLOps is not just about technology, it's fundamentally about collaboration. It brings together cross-functional teams from data science, engineering, and operations to work closely on machine learning projects. This collaboration is essential because each group brings a unique perspective and skill set crucial to the success of machine learning initiatives. Data scientists develop and refine models, Engineer architect the system that will run these models, and operations ensure these systems are scalable and efficient. Tooling plays a vital role in facilitating this collaboration. Version control systems, integrated development environment, which is IDEs, and experiment tracking systems are just a few examples that can help streamline the machine learning lifecycle. Version control allows teams to manage changes to the code and models systematically. It ensures that everyone is always working on the latest version. IDEs offered a shared space where data scientists and engineers can write, test, and debug code more efficiently. Experiment tracking system helps keep a log of all experiments, including parameters, metrics, and outcomes, making it easier for teams to collaborate on finding the most effective solutions. Effective communications and documentation holds these collaborative efforts together. They ensure that every team member, regardless of their role, can understand the project's goal, progress, and challenges. This clarity is crucial for fostering an environment where knowledge sharing is encouraged. Sharing insights, learnings, and even failures helps team avoid repeating mistakes and builds a culture of continuous improvement. Lastly, standardization across tools, process, and communication ensures that collaboration is smooth and productive. Now I will talk about best practices in MLOps. One is start small and scale. It's good to kick off MLOps journey with smaller, manageable projects. This approach allows us to test workflows, tools, and strategies without overwhelming team or resources. As we get success and learn from initial challenges, we can confidently expand MLOps practices to larger and more complex projects. Another is embrace experimentation. The field of machine learning is inherently experimental. It involves a lot of trial and error. So by adopting a experimental mindset within MLOps, we can create an environment where innovation happens. Another is focus on quality data. Garbage in, garbage out is particularly true in machine learning. Ensuring that the data is of high quality is very important. So we should really focus on cleaning, validating, and regularly updating our data. Another is security and compliance. As machine learning models often handle sensitive information, we should often prioritize security and compliance. Next is continuous monitoring and retraining. Deploying a model is not end of the road. Continuous monitoring is essential to ensure models remain accurate and effective over time. Next is choosing the right tools. The tools and technology we select for our MLOps practices can significantly impact our team's efficiency and the success of our projects. We should opt for tools that not only fit the current needs but also scale with the projects.